Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on ellipses. As you have learned in this unit, both parabolas and ellipses can be formed when a slanted plane intersects a cone. In the last lesson, you learned how to write the equation of parabolas. Today, we will study the equations of ellipses. Are you ready, students? Let us begin. Do you know the difference between an ellipse and a circle? They are similar in appearance, but their shapes are actually quite different. A circle has only one reference point, its center. The distance from any point of the circle to this reference point is the same. An ellipse, on the other hand, has two reference points called foci. The sum of the distances from any point on the ellipse to the foci is constant. This definition will be clearer once we learn the terminologies for ellipses. The foci of an ellipse are denoted as F and F prime. The line running from one end of the ellipse to the other through the foci is called the major axis. Here it is represented by the line from V to V prime. V and V prime are the vertices of the ellipse. There is a second set of vertices. B and B prime are on the minor axis. The minor axis runs perpendicular to the major axis at the midpoint of the ellipse. The center of the ellipse, C, is found at the intersection point of the major and minor axes. The distance from the center to a focus is denoted by a small c. Because an ellipse has two reference points, it has twice as many parts as most of the other shapes we have studied. We have more terminology to learn, students. The lines from C to V and V prime are called semi-major axes. The length of the semi-major axis is denoted by a small a. Lines from C to B and B prime are called semi-minor axes. The length of these lines is denoted by a small b. The chord AA prime, which is perpendicular to the major axis and runs through one of the foci, is the latus rectum of the ellipse. An ellipse has a special property called its eccentricity. Denoted by a small e, the eccentricity of an ellipse is the ratio of the distance between the two foci to the length of the major axis. We can determine eccentricity by taking c over a. E will be a number between 0 and 1. When E is 0, the ellipse is a circle. As E tends toward 1, the ellipse has a more elongated shape. In order to determine the equation of an ellipse, we must consider two cases. In the first case, the center of the ellipse C is at the origin of the xy coordinate 0, 0, and the major axis is horizontal. The standard form of an equation for this ellipse is x squared over a squared plus y squared over b squared equals 1. This equation is derived from the right-angled triangle formed by joining B with C and F. By Pythagoras' theorem, we get CB squared plus CF squared equals BF squared. Since CB equals B, CF equals C, and BF equals A, then we get B squared plus C squared equals A squared. Students, you will use these relationships and equations in this activity. Write the equation of an ellipse whose foci are -3, 0, and 3, 0, and whose measure of A is 8.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. If these are the coordinates of the foci, then C must equal 3. By using Pythagoras' theorem, we get b squared equals a squared minus c squared. This means that b squared equals 64 minus 9, which equals 55. Therefore, the equation of the ellipse is x squared over 64 plus y squared over 55 equals 1. What if the center of the ellipse is at HK and not the origin? This means that we must translate the original x and y coordinates by h and k respectively. So the equation for an ellipse whose major axis is horizontal and whose center is at HK is as follows: x minus h squared over a squared plus y minus k squared over b squared equals 1. Where before v was at plus or minus a, 0, now it is at plus or minus a plus hk. The location of f changes in a similar manner. The eccentricity is c over a. The length of the major axis is still 2a, and the length of the minor axis is still 2b. Please note, students, that if the major axis is vertical rather than horizontal, we switch the positions of x and y in the equations. So this becomes this, and this becomes this. Students, please try this activity. Find the equation of the ellipse with center at 1, 4 and vertices at 10, 4 and 1, 2.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. Sometimes the easiest way to begin an activity like this is to draw the location of the points. C is at 1, 4, so H equals 1 and K equals 4. We can see that the vertex at 10, 4 must be at the major axis V. The distance from V to C is A equals 9. The vertex at 1, 2 must be at the minor axis, B. The distance from B to C is B equals 2. Now we can substitute into our standard equation for an ellipse. The answer is x minus 1 squared over 81 plus y minus 4 squared over 4 equals 1. Was this your answer, students? I am sure that your teacher can provide you with many more exercises to practice what we have learned. Today, we have studied the parts of an ellipse, and we learned about their relating properties. We also learned how to write the standard equation for horizontal and vertical ellipses with varying centers. Next time, we will discuss hyperbolas. Until then, thank you, teacher. Thank you, students.